Hello, everyone. In this lesson, we're going to talk about derivative at a point. What is derivative? What kind of question we're trying to solve by introducing the word derivative? Okay, first of all, we have these two graphs. Okay, let's look at the one on the right. We are interested in, okay, so this point P is a comma f of a. So it's a point A. Okay, these A are the same point. We want to find the slope of the tangent line. And the red line is the tangent line at the point A comma f of a at point P. Okay. And we don't have a formula for it. So we're going to use the idea of rise over run, right? So we choose another point Q, which is in the, nearby, which is very close to P. And between P and Q, we find the rise over run. So AX, so X minus A is the run, and f of a minus f of x minus f of a is the rise. So rise over run. So we set up and we want to approximate. So rise over run. Okay. So this is the slope of the line, of the blue line, right? But we will take a limit. We're going to take a limit. And limit is taken for x is approaching A. So x is getting closer and closer to A. Okay, so as x is getting closer and closer to A, the blue line, the blue line, you can see the point Q is getting closer and closer to P until the point Q is infinitely close to P. So that's the limit that we're going to look for. And we define that limit, if that limit exists, as the slope of the tangent line, which is the red line. In other words, the limit, right? The limit we set up here, if it exists, is defined as the slope of the tangent line, which is, let me draw that line on this piece. Okay, so that will be the slope of the, let me use red. Okay, I'm going to use red. Okay, so that'd be consistent with the other line. So that will be defined. So this limit is defined as the slope of the tangent line at A. At A. Okay, so that's our definition of derivative at A. So derivative at A acquires the meaning of is the slope of a tangent line to a point on the curve, because P is a point on a curve. All right, so let's move forward. Okay. So here's the definition. The definition, as we said, the tangent line to the curve at that point is a line through P with the slope. If this limit exists, and that limit is going to be the slope of the tangent line. Now there's some variations about this definition. For example, right, in the previous picture, we used AX, right, x minus A, f of x minus f of a, so rise over run. So suppose we assume, right, the difference between x and A is h, right? So this is H. And formerly, it was X minus A, right? Formerly it was X minus A. So H is X minus A. So that former definition becomes, you can see, I'm going to write it down here. Okay, so H equals to X minus A. And then X would be equal to A plus H. So that's how we change f of X minus f of A become f of A plus H. But when X approaching A, right? When X approaches A, when X approaches A, H as the difference between X and A certainly approaches 0. So we get the alternative definition of slope. We got alternative definition of the slope. And there's another version. There's another version. Let me clean this up. Okay. The other version is, it wasn't written in the textbook, but so we have these two versions already. There's another version. The other version is that we call H. Instead of calling it H, we call it delta X. Okay, I'm going to find that symbol. It's a triangle. It's a triangle shape. I shall find it somewhere here, right here, delta X. So H is sometimes used as delta X. So that is X minus A. So we will have another version of this limit, which is F prime, or if the limit exists. Okay, and that will be equal to the limit, right? This limit will be changed to, so this time if delta X approaches 0, and over here is going to be X minus A is delta X, right? So this is going to be XA plus delta X. So it's another version. Okay, this version actually is also used very often. And the next form, so we already have 1, 2, 3 forms. The next form is that we're going to call x1, x2, right? You can see instantaneous rate of change, right? F of x2. So we're going to call x, okay, we're going to call x sub 1 as A, right? X sub 2 as A plus H. So that's how we get this other form, which is called instantaneous speed, rate of change. They all derive from the same idea. So, but in this case, we call it, okay, so you can see, we see delta X now, right? Delta X. So delta X is basically X sub 2 subtracting X sub 1, right? And that's X minus A, right? And delta Y, which is, this is the variation. So delta Y is the difference in function. So that's going to be f of x1, or f of x2, subtracting f of x sub 1. Okay, so that's how we get, so essentially these definitions are all the same. And they all stem from the same idea. It's just how you call it. You can call this one x1, x2, or you can call the difference H or delta X. For this moment, okay? This formula is more preferred. And of course, you also have the opportunity to use this other one. So these two formula, we're gonna put it next to each other. Okay, they can be used interchangeably. They can use it interchangeably. So let's see how we apply the definition of derivative. Okay, so now we already have the definition of derivative. So next, we're going to see how we can find the equation of the tangent line to a curve at a given point. Okay, so let's look at this first example. Okay, let's look at this first example. So first of all, let's look at the curve. Let's look at the curve. So we're gonna graph the curve, right? And the point of our interest, is 2, -4. In other words, if we treat this as a function, that equals to x plus 2 over x minus 3, and when we plug in, right, when we plug in f of 2, we will get, we plug in that, right? So this is 2, and that is 2, and we're gonna get -4. So this is a point on the curve. It's a point on the curve. Okay, so we're gonna plot this point on the curve. So 2, -4. I'm gonna make it a red dot. Okay, so this is the dot. This is the point. And we want to find the tangent line. We want to find the equation of the tangent line to the curve at that given point. In other words, we want to find that tangent line, presumably, right? We can draw it for ourselves just to take a look, right? It's approximately something like this. So this is the tangent line. And we want to find the equation of the tangent line after we find the slope. So that's the idea. Okay. So now, and of course, first we want to find the slope. And knowing the point is, now we have A, right? A is 2, f of A, f of 2 is -4, right? So we're gonna plug in. Now we're gonna find the slope. The slope is, if this limit exists, right? Limit, so we're gonna use two different formula to do that. So x approaches 2, right? X approaches 2. And we're gonna find f of x, subtracting f of 2, and x minus 2. So we're using one of these two formula. Okay, one of these two formula. So I'm going to bring these two formula with us. Okay, so we use the first one. We're using the second one, sorry. All right, so it's a matter of plugging in. Okay, so let's see what we got. The function, right, f of x, we know f of x is x plus 2 over x minus 3. And f of 2 is -4. And we got x minus 2 in the denominator. And we simplify a little bit, a negative of -4 is +4. So this is going to be +4. And then we're going to reduce this fraction form. Okay, we're going to reduce this fraction form. And how do we simplify this complex fraction? Well, we know how to do that, don't we? So we just multiply the common denominator. Okay, you can do it this way. Okay, the common denominator we have, this is a complex fraction. So fraction 1, fraction 2, and fraction 3. X minus 3 is the common denominator of all 3 fractions we just mentioned. So we're going to take this x minus 3, multiply that piece. Okay, so we're going to move to the next step. Okay, so we're going to have, so x minus 3 times that, and times, we need a parentheses here. Let me put 300% here. Okay, and x minus 3 is also going to multiply 4 times 4. And x minus 3 will also be multiplying x minus 2. Okay. When we do algebra, we must be very patient with ourselves. Now, so this piece, x minus 3 canceled with or reduced, we get x equals 2 left. Okay. And you might be thinking, can we directly substitute? And obviously not. Okay. Let's reduce the numerator. Okay, let's reduce the numerator. On the numerator, we're going to open up the parentheses, 4x minus 12. And so this is going to make it 5x minus 10, right? 5x minus 10. 5x minus 10 can be factored. We factored out the 2. So that's become 5 times x minus 2. And now x is approaching 2, but not 2. So x minus 2 is not 0. And the next step is that we can reduce x minus 2. And now we can do direct substitution. Direct substitution, replace x by 2. So we get a -5. We get -5. So the slope is -5. The slope is -5. Once we know the slope, right? And we also know the point and point slope formula for the slope of the tangent line, the equation of the tangent line. Okay, we're going to use slope point formula. Okay, so the tangent line that passes the point 2, -4 is the formula. We have y minus y sub 1 equals to, this is the point slope formula. Okay, x minus x sub 1. Okay, so we just substitute. Y1 is -4, x1 is 2, slope is -5. And simplify, so we got y equals to -5x plus 10 minus 4 plus 10, right? This side of plus 10 minus 4, that's plus 6. Okay. Let's see. Let's put this tangent line in the picture. Let's put this tangent line in the picture to see if it makes a tangent line. Okay, so we're going to do tangent line. We're going to use what color? Red. There we go. There we go. We got the tangent line equation. Okay. Oftentimes, you may not be asked to just to draw it, but it's, you know, it's not too hard to draw it. You just sketch it. It's a sketch, okay? We use one of the formula to find the slope. Or I like to show you some algebra to find the slope using the other formula. Okay, so I'm going to set this up. And so the other formula would be h approaching 0. And this will be h, right? So this is going to be 2 plus h f of 2. So we're using the second formula to find the slope. Okay, to do that, okay, we got our function. So let's see, where's our function? This is our function. Okay, this is our function. Okay, so f of 2 plus h is, here's 2 plus h, and this is 2 plus h, right? And simplify this a little bit. So we got h plus 4, and this is going to be h minus 1. Okay, so on this formula, f of 2 plus h is substituted by this fraction form. F of 2 is -4. Okay, so we get a slightly different looking form. And you could use this one. Okay, you don't have to do both. Usually you just have to do one. I'm just showing you the algebra involved. I'm just showing you the algebra involved. It doesn't matter which formula we use, we should get the same answer. We should get the same answer. So now once again, the, you know, the technique, right, is h minus 1 is a common denominator. H minus 1 is a common denominator. You see, I line up the equal sign at the same level of the longer of the fraction bar. Okay, and then when I'm doing that, so h minus 1, so this time we can do a bit faster, right? We're going to multiply this piece, so we're going to have h plus 4, and here it's just going to be multiplying h minus 1. H minus 1 is going to multiply h, so this part is gone. Excuse me. So we're going to simplify. So this is going to be 4h minus 4, right? 4h minus 4. So this is going to be 5h, right? So -4, +4. So this is going to be 5h. And how about this piece, right? To stay the same. And h and h will be reduced. So after that reduction, h and h will be reduced, and we can directly substitute. When we directly substitute h equals to 0, and we get the same answer, -5. And the rest to find the equation of the tangent line is the same. Point slope formula. Okay, point slope formula. All right, so let's look at the second example. And this time we got a root function. Okay. And of course, for this root function, we can also draw the picture, right? We can draw the picture and just to verify, right? So you can view this function as is equal to f of x equals to that. When we plug in the input a, right? So our a is -1. So this is going to be -1, right? So this is going to be equal to root of 4, okay, that's 2. So this is indeed a point on the curve. So if you like to draw the picture, you could, even though it's not absolutely necessary, because you can go straight to find the slope, So this is the curve, and the point of our interest is -1, 2, right? So it's a -1, 2. It's a red dot right there. Okay, so I'm going to make some adjustment. So, okay, so a little bit simpler. Okay, and so we anticipate there is a tangent line, so we're going to find the slope. And this time we're going to use this first formula directly. Okay, so we're going to write f prime of -1. It is equal to the limit as h approaches 0. Okay, this quotient, which is f of -1 plus h minus f of -1 divided by h. Okay, so a is -1, right? And so that's how we plugged in. And we're going to proceed. Over here, we got this equals to the limit, right? And we're going to plug in f of -1 plus h, So f of -1 plus h. So this x will be replaced by -1 plus h. Okay. Simplify. We have that opened up the parentheses. So -3 times -1, and that's going to be +3. And it's going to be -3 times h. Okay, and this makes 4 minus 3h. Okay, -1 plus h, plug in this function, x replaced by -1 plus h, opened up the parentheses, -3 times -1 is +3, and 3 plus 1 is 4, -3 times h is -3h. So this piece can be replaced by that radical. Minus, right, f of -1 is equals to 2. So this is 2 divided by h. Okay. And obviously we cannot directly substitute because it causes 0 denominator. So we're going to use our common, the method we already know, which is the conjugate. So we're going to multiply the conjugate, which is +2, right, divided by the same quantity. So this whole piece is 1. Anything times 1 stays the same. Equal sign is justified. And the next step, denominator, multiply the denominator, and numerator times the numerator. So we get that, multiply, right? Numerator times the numerator. And this makes a minus d times a plus b. So we ended up with that a squared minus b squared. Okay, so the routine. If you need to pause and you do your own, I will highly encourage you to do that. After this, we got 4 minus 3h minus 4, right? So 4 minus 4, that's 0. So the next step, we're going to have negative 3h on top. H and H reduce. You could write less step than I. And H and H reduced. Now we no longer need this parentheses. Now we can directly substitute. When we directly substitute, we can remove the limit sign and just replace h by 0. So in the end, let's see what we got. The top is negative 3, the bottom, root 4 is 2, 2 plus 2 is a 4. So now our slope, right? Our slope, obviously the limit exists. Our slope is the derivative of the function at negative 1 is equals to negative 3/4. So once we found the slope, we just use point slope formula. Y minus y1 equals to slope multiply x minus x sub 1. And what is x1, xy, x1, y1? They're here. Right, so the point is that one. So we just plug in, that's subtract 2, that's subtract negative 1. M is negative 3/4. Negative 3/4. Okay, we'll organize the term a little bit. So we got y equals to 2 plus on this piece, negative 3/4 times x, not c, and negative 3/4 times, this is a plus 1. Okay, so it's a minus. So this is minus, and that's going to be minus 3/4. So we need to organize a little bit. Okay. Now y is equals to negative 3/4 and 2 minus, right? 2 minus 3/4, what would that be? 1 minus 3/4 is 1/4, so that's going to be 1 1/4. That's it. Or you want to write 5/4, that'll be fine too. Right, 5/4. So let's draw this line to see if we get a tangent line. It should be, right, that's the tangent line. Okay, so that's the general procedure to find slope of tangent line, and then find the tangent line equation itself. Okay, let's see, we have some more examples. Okay, and this one is asking us to, I took these just to show you, and I want you guys to practice with me. We're going to use this formula to find the derivative of f at a. This time we're not given any specific point. So what do? Right? We're going to plug in f of a plus h. So now a is arbitrarily chosen from this domain. So for a, right? F of a, and what is f of a plus h? A plus h. So this x will be replaced by a plus h. Here we go. We got f of a plus h minus f of a. And then we're gonna compose. Well, if you like, you could do the following. You don't have to, attach all the limit all at once, right? You could do the following, okay? I'm not taking the limit along with me, so I started to work on only the part over here. So what I'm going to have is f of a plus h right here, minus f of a, which is right here, divided by h. Okay. Do you need to do anything inside? Not really. You can just leave it like that. Okay. So we know that if we take limit, we cannot directly substitute because that's going to cause a zero denominator. So we're going to use our old trick, right, which is the conjugate of the numerator. So we're going to rationalize the numerator. We're going to rationalize the numerator. And then what do we get? The denominator, right? The denominator is going to be multiplying the denominator. So don't try to multiply out. Okay, just leave it in the parentheses. The numerator is a minus b times a plus b. So it's simply just going to be this piece and squared, right? All right. Do I need to remind you that we are doing a minus b times a plus b equals to a squared minus b squared? I think you know that pretty well by now. And then this piece, because this is a root of something squared. So, and then we can just drop that, right? And this is a root something squared and there. But don't forget, we should have a parentheses here. Okay. Now we're going to reduce. Now we're going to carefully reduce. 4a plus 4h. So this is a 4a plus 4h minus 4a minus 1. Okay, opened up the parentheses here, right? We get minus 4a minus 1. 4a minus 4a makes 0. Positive 1, negative 1 makes 0. So our next step, we only have 4 times h. We only have 4 times h. Okay, so 4a takes away the negative 4a, negative 1 plus 1. And h will reduce. So h and h will reduce. By this time, we figure we can do direct substitution. Now we are going to take limit. Okay, we're going to take limit now. Okay, limit as h approaching 0 is the same as this limit on the whole of that part that equals to the left-hand side. Now we can do direct substitution because no worries about 0 denominator, right? So this piece, h is going to be substituted by 0. How about a? Well, a is going to be left. And what do we get? Right? The top is 4. The bottom, you can see this is just a, so 4a. So we have 2 of that. So we have 2 times root of 4a plus 1. So if we reduce it, we're going to have 2 over 4a plus 1. That's it. And we found it, and that's the derivative. Okay, you can see algebraic skill is very, very important here. All right. We have 2 more questions. I tried to give you guys a variety of questions which you may find difficult algebraically. We're not doing 6 and 7. That's going to be another video. Okay. Number 4, but we're going to use this formula. We're going to use this formula. Okay. For number 4, to use this formula, right? We have f of x already, and we're going to have f of a. So x replaced by a. There. Okay. So we're going to compose this piece first. Equals to x minus a, we keep it, f of x, right there, subtracting f of a. All right, complex fraction again. So what are we going to do about it? Common denominator, okay? Be careful that we write it. Make sure you have the right proper alignment. Otherwise, you may get confused. Okay, the common denominator is 1 minus 4x multiply 1 minus 4a. Okay, and the same for numerator and denominator. And you know what the drill that comes next, right? We're going to take the whole of it, multiply this. I'm going to take the whole of it, multiply that, distributive, and take this piece and multiply x minus a. All right, so I'm going to show it to you. Okay, so we're going to do step by step. I'm going to do step by step. So this piece, multiply that, also multiply that, right? So this has 1 left, and this piece, we're going to multiply it with x minus a, so we need to insert a parentheses. We don't need that layer of parentheses. So this piece is gone. I'm going to do reduction here. 1 minus 4x, take away 1 minus 4x here. So it just will be x. 1 minus 4a takes away 1 minus 4a, and this is just be a. Oops. Okay, 1 can be omitted. All right, be patient with yourself. Don't try to multiply the denominator, just leave it as the factor form. So next, we're going to, on the numerator, we're going to multiply out. So x times 1, that's going to be x, and x times 1 and x times 4a, so 4ax. And a times 1, so that's a times, negative a times 1, that's minus a, negative a times negative 4x, that's a plus 4ax. It's a plus. Boom. Okay. And now by this time, we can see we got some opposites. We love opposites. Positive 4ax takes away this piece. So we have x minus a on the top. The x minus a, x is not going to be a because x approaching a, x is not a. So these two will reduce. There we go. Finally, we get to something manageable. So now we're going to take limit. Now we're going to take limit. We're taking limit, and that limit, because we have worked on this part so diligently, We got that. Now is direct substitution. Okay, direct substitution, replace x by a, and dropping the limit sign. And that's a. And we have a square. So in the end, obviously this limit exists. So for this particular function, the derivative is equal to 1 over a parentheses being squared. And inside the parentheses is 1 minus 4a. So let's look at the last one. The last one, we're going to use that second formula again, but this time the algebra may be a little bit more demanding. Okay. As always, make sure you work closely with paper pencil as you're watching. Okay, we have f of x already. And we're gonna compose f of a. Okay, this will be the perfect opportunity for you to enhance your algebra, because not only we have so much algebra here, we're gonna have a lot of more algebra in soon. Okay, in later chapters. So now we're working on this piece. So x minus a, stay there. F of x minus f of a, right there. Okay. You know, one of the things we can do is that we can factor out the 4, if you like. If we can factor out the 4. Okay, this is what I meant. So we can factor out the 4. Okay, so this 4, we're going to take it out, factor it out, right? We're going to put the 4 over here. Okay, so it looks a little bit simpler. And then we're going to work on the common denominator, right? The common denominator obviously is going to be root of x, a root of 1 minus x, and the other one is root of 1 minus a. I'm not going to make any attempt to bring them together. No, I just leave it in factor form like this. Okay, trust me, this will work better and easier. And the next step, we're going to take this piece, as always, multiply that piece, and multiply that piece. And of course, this whole piece is going to multiply x minus a, and there. And I'm going to reduce, this makes 1, and this piece and that piece is gone. Make 1, okay? And then what do we do? If we vision, we can substitute by, can we substitute x by a? No. Because that's going to cause zero denominator. We cannot apply them in law. So once again, rationalizing the numerator. So the conjugate of the numerator is the one root plus the other. So plus. So we're composing that number 1 right there. Right? Now, denominator, you can just leave it there, actually. Yeah, sure. And these 2 is a minus b times a plus b again. So that's going to be a squared minus b squared. And this is just 1. Okay, we can just leave it like that. Okay? And what do we get for the next step? Well, it's going to be 1 minus a. This is going to be 1 minus x. So we need to have a parentheses for 1 minus x. Now, what do we have? Opened up the parentheses. So minus 1 plus x. So 1 minus 1 is 0. So we have minus a plus x. So this whole thing is just x minus a. Okay. While x is approaching a, x is not a by definition of limit, right? So x minus a and x minus a in top and bottom in denominator and numerator will reduce. Boom. So now we're so close to the answer. Now we can finally take the limit. You can bring them together, but it's not really necessary. Okay. So now we're gonna take the limit. We're gonna take the limit. Okay. Number 6 and 7 will be in another lesson. Okay. So now that limit is simply going to be the form that we worked out, taking this limit. Can we directly substitute? Yes, we can directly substitute because no worries about common denominator, the zero denominator. So x is turning into a, x is turning into a. Look what we got. This piece is just 1 minus a, right? Because that's root 1 minus a squared. Right? So that's just 1 minus a. And on that piece is twice, just 2 times. 2 times. Simplify further, and the 2 and 4 will reduce. So this is going to be a 2. So now we don't have that. We have 1 minus a here. We have root 1 minus a. If you think of this as power 1, you could combine the power. Okay, you could combine the power as 2 over 1 minus a to the power of, with that power 1, that's power half, that's going to be power 3 half, if you like. If you don't, you can just leave it as this form, okay? Or another form, you can keep the answer as 2, which you're going to have 1 minus a, and the root of 1 minus a. That's your answer as well. So either one works, okay? Either one works. So the derivative at a for this function is that piece, or that piece, or another piece, which you may like to write it this way. These are all different ways you can do it. This is a negative exponent. And any one of the 3 forms work, okay? I think that's all for today. And today's lesson is primarily about introducing derivative and how to find tangent line equations by finding the slope of the tangent line first, and then plug in the point slope formula. And we've seen the different forms of derivative. Okay, let me do a little summary here. Okay, so this is one form. There's another form, h approaching 0. So this is the h. Okay, a plus h, f of a. Next form. Okay, the next form, I'm going to use that delta x. Delta x. Okay, delta x. Delta x. So h is substituted by delta x. You don't see that in textbook yet, but you will see it at some point. Okay. And the last one is this piece over delta y. Okay. Delta y over delta x. So this is delta y. So these are form number 1, number 2, number 3, number 4. They all do the same thing. If one limit exists, all the other exists. Okay, because they're just different ways of expressing it. If the limit exists, the limit is denoted as the derivative of the function at A, so f prime. Okay, f prime. So in other words, the derivative can be written as all of these different forms, any one of these forms. Okay. Oops, what did I do? So they can be written in all of these different forms. Okay. You can use any one of these forms. Any one of these forms. Any one of these forms. Okay, all different forms. You can use any one of these forms to find the slope, right? So that's also the slope of tangent line. So in order to find the tangent line equation, we just use the point slope formula. Y sub 1 equals to m multiply x minus x sub 1. Okay, so that's what we did today. And we also use any one of these formulas. We didn't use this formula. We did not use this formula. Okay, we used the first two formula to find the slope of a tangent line or the derivative at A. Okay, that's all we did today. Thank you for watching.